Our next speaker is Dr. Eric Schmidt, the Global Director of Strategic Analytics at International Hotels Group. Dr. Schmidt has over 15 years of international experience structuring complex business questions, developing analytical tools and capabilities, translating analytics into actionable insights, communicating recommendations to senior stakeholders, and building and cultivating highly effective analytics teams. Eric currently leads IHG's Global Revenue Management Operations research function across its portfolio of hotel brands and guides the function's analytics strategy for methodology and technology. Prior to joining IHG, he worked for SunTrust Banks, where he managed the credit risk model validation team for the CRO, Georgia Pacific, where he developed pricing and revenue optimization systems for sales and category planning, and the Coca-Cola Company, where he led development of marketing investment strategies and analysis and planning frameworks and organizational capabilities. Dr. Schmidt holds degrees in engineering from the Georgia Institute of Technology, where he studied mechanical engineering and fluid mechanics, and an MBA from Emory's Goizueta Business School, where he focused on marketing and decision sciences. He received academic scholarships both at Georgia Institute of Technology and Goizueta Business School. In 2011, Eric received the Marketing Faculty Honor Award as the top marketing student in that graduating class. Please welcome Dr. Eric Schmidt.
All right. If I would have known we were going to read that, I probably would have shortened it a little bit. I feel like, did anyone watch Game of Thrones? Khaleesi, like her title just went on forever. So thank you for having me come and talk to you today. When Amelia reached out to me about this, she's like, well, what do you want to talk about? And I started off with, these data science things can be a little bit dry and boring sometimes. So I said, at first, I was like, well, let's do like a stand-up routine, a stand-up comedy routine about data science. And she said, try it out, and I threw a few jokes at her. She didn't laugh, so we decided to go a different direction. So, after lunch, last, presentation or two of the day, I thought, what would really get them excited and interested in data science? So I said, well, let's just talk about forecasting. So hopefully that fits the bill. And Vishal told me that this is actually the spot that you're supposed to stand on, and nobody has stood on this spot while they were presenting the whole time. So I'm just going to stand here for a minute so you guys can, fulfill the red dot here. So, but yeah, so my head kind of blocks the video, so I'm going to move now. Okay. So, yeah, now, okay, all right. So, forecasting. What's interesting about forecasting? What are we talking about? Forecasting, data science. I'm gonna start from the beginning. The very beginning. We've been doing forecasting since the dawn of civilization. So this is like the Mayan calendar, and the Mayan calendar has been in the news the last couple years. But calendars were really the first kind of forecasting model. It's like what are the seasons going to be? What's the weather going to look like? What's the moon, the phase of the moon going to be essentially? So it's really observational. And so, we're wired to try and find patterns or see patterns, and this is how these calendars, got developed. And so they would look at the sky and they'd see the moon change over time, and they would recognize that, this repeats. And if they were to do a time series chart, this would be what it would look like. You would see a spike or a peak at full moon, and so that would be your first time series graph if they were to do that, but they made it into a calendar. So they also looked at, weather patterns and, other things that were going on in the environment. And why were they doing this? They were doing this because they wanted to know how to feed themselves. They had to figure out when to plant the crops, when they should hunt. So this is, it's the necessity is the mother of invention kind of thing. So 5,000 years later, it's not much has really changed. We're still trying to forecast stuff so we can feed ourselves, right? We do it in a kind of indirect way. We do it to make money in our job, in our company, et cetera. But we're still trying to feed ourselves ultimately at the end of the day. But it's a little bit more complex. The models, the data, things are more complex than maybe 5,000 years ago. And so these are just some examples of things that you might want to forecast, right? So we actually invented math to address these forecasting challenges. So there's this area of statistics called time series modeling. And the two kind of main approaches, I would argue, are exponential smoothing and autoregressive moving average, or REMA models or ARMA models. And those are kind of the standard bread and butter time series forecast models. So when we talk about traditional models, this is what we're talking about. So the concept of these time series approaches, basically time series can be represented or broken down into various components. There's potentially a trend, which is indicated here by this trend line, and then seasonality. We see patterns, and if we see that same spike happening at the same time each year or each week, et cetera, we can say, okay, well, there's some pattern here that maybe repeats itself. There's also potentially randomness in the data. There's always some amount of randomness. And then there's also potentially variance. So the scale of your time series might change over time. In this case, it's monotonically increasing over time. It could change back, it could get smaller in some time series. But those are kind of the basic components. And those time series models that I threw up there before are basically designed to determine the parameters that characterize these time series, right? Am I throwing you off by like moving in front of the mic? No? Okay. I can go stand on the spot again, maybe. But this is it. I mean, and what's interesting about time series is all you need to know about predicting the future is what happened in the past. I mean, that's the assumption of time series, is you look at what's happened in the past, and if it repeats itself, you kind of assume that it's going to continue to repeat itself. So you just need to characterize what's happened in the past and then project it out going forward. That's the beauty of time series models. So we're pretty successful at it, but business managers are still skeptical about it. So does anyone do forecasting as part of their job? I'm sorry to hear that. I do as well, and it's very tough because you're always wrong, right? You're never exactly right. And then you have business managers, your stakeholders, who think, in a lot of cases, they can do better than the statistical model. And there are a few reasons for this. I pulled this off of a SAS blog, essentially, from there's a blog characterizing a talk given by Paul Goodwin from the management school at the University of Bath. And he did some analysis or some study, and basically the statistic here is that even though companies invest heavily in statistical software and time series modeling software, about 93% of the time they're adjusting those time series outputs with subjective kind of overrides. That's a pretty high number. It's like, well, you've invested all this money in this platform. Why are you going and adjusting it? And so there are a few reasons for that, and I think these are good reasons, actually. So one is an anchoring issue. So we have a tendency to want to stick close to what has been happening. So if you see kind of a shift in the forecast, there's a tendency not to believe it, right? So if the forecast says, hey, you're going to see a big increase or a big decrease, subjectively you might say that doesn't feel right, that's out of place, I'm anchored by the past. There's also, again, we're wired to see patterns, and I see this a lot in my interaction with my stakeholders, where in the randomness, somehow a pattern will pop up, and they'll say, well, see, this is what's happening. I can see this happen, right? And I'm like, yeah, I guess. I don't know. And that's how some of the forecasts get overridden. And then in other cases, we have folks who want to be the forecasting guru. So they'll make adjustments to the forecast, although pretty small adjustments, to say that they've put their special touch on it, and it wouldn't be as good unless they put their special touch on it. And in one case, there's a process we have at my current company where there's a statistical forecast, and then they have, I call it the accounting method. They'll put in kind of the overrides in the in this Excel spreadsheet, and they'll say, Trump tariffs, they'll say, the hurricane, et cetera, and they'll make adjustments. And it's like, that's great. How are you coming up with these adjustments? Like, well, that's my secret sauce. So that's very interesting. And then what I did is I summed up all the adjustments they made, and they basically came out to be zero. So they had all these adjustments that netted out to be zero. So in essence, they were producing the same time series forecast, but it made it look like they were producing something of their own. And then, we want to provide, optimistic results. So there's a tendency to want to do that. And I think that's especially true if you're in a business forecasting process where management's asking you to provide a forecast, and it's maybe bad politics to say, oh, well, we're going to see a decrease. I mean, the expectations were going to increase, right? So there's an optimism bias, which is closely related to the political bias, which is, depending on what the management, current thinking is, I think forecasts tend to get adjusted or tweaked to meet those expectations. The other thing I think that's important to note is forecasts are not decisions. So we get asked to do forecasts, and there's a difference from we need to grow by 100% or 200% next year versus we think we're only going to grow by 50%, right? The forecast isn't saying that's what we need to do. It's saying that's what we think we're going to do. But if you think we need to do 100%, what do we need to do differently, right? But oftentimes the folks doing the forecasts, I think, kind of get criticized for management because the forecasts don't reflect what management thinks they should do. So, but still there are these kind of biases, I think, that work against forecasting when forecasting should actually be believed. But in some cases, it's actually wrong. Has anyone seen this in your kind of time series where it's going along pretty well, and then all of a sudden, what's happening there? Well, that could be the hurricane. That could be the asteroid that hit last week, right? So there are some cases where there's good reason. So, but these things are, these like kind of long tail things, I think cause credibility issues with the forecasting processes, right? So we should try to account for these if we can, but this is I think one of the key reasons why forecasting processes are not fully trusted. So here we are in the data science era, right? So there's a little bit of, well, if we had machine learning or AI, we could catch that. Machine learning could do better than that, right? So, I would ask, can machine learning simply applied to the same data do any better? Probably not, right? Because it's not a methodology issue in this case. It's a data issue. There's something missing in the data that the time series didn't pick up. And I don't think throwing machine learning at it would do any better. So that brings me to the infinite monkey theorem. Has anyone heard of that? All right, well, I thought I would share something new, but I am talking at the data science conference. So, I forget where I picked this up. It's probably back in my undergrad at Georgia Tech, but it's basically the concept is the way I heard it is if you had 1,000 monkeys typing on 1,000 typewriters for an infinite amount of time, eventually they would be able to produce the complete works of William Shakespeare, right? So by some process, so through randomness, like William Shakespeare's works would all be replicated by monkeys. I think this is kind of the data science fallacy that I'm hearing a lot about, which is if we had enough data and we had enough cloud computing and machine learning algorithms, et cetera, you just push it all into the cloud, hit run, and ultimately the right answer will come out, right? So to me, that's the infinite monkey theorem at work here in data science. So I would challenge that thinking around, is machine learning or AI the cure for, traditional methods that aren't working? Just as another aside, so this is all, Wikipedia research. So apparently, a group in the UK at the University of Plymouth took a 2,000-pound grant from the Arts Council to study the output of monkeys typing on a typewriter. They actually did this. I thought this was hilarious. But so not only did they not produce Shakespeare's work, they produced only about 5 pages of content, largely the letter S. The lead monkey apparently started pounding on the computer with a rock, and then the rest of the monkeys soiled it, I guess is the way they put it. So maybe we should try that with forecasting and see if we can get a better forecast. But so, I mean, this comes down to, again, if there's a pattern in your data, I would argue time series approaches are already pretty efficient at spotting that pattern, at forecasting what will happen. Machine learning methods, by contrast, they may do as well, but they're going to require a lot of data. There's probably a lot of intensive labor that's needed to create all those features, those data features. And I would argue, well, your feature engineering of your time series is probably at best approximating what the time series model is already doing. And then you're spending all this time and work doing it. And then it's going to take a lot of time, computation time, to actually produce an output, right? So I think time series models probably do pretty good as is, right? On the other hand, if your data is all random, neither the time series nor the machine learning algorithm is going to do anything with it because it's random. By definition, it won't have any output. So I would say time series methods are still probably a strong candidate for producing your forecasts. This is backed up by some academic research. Has anyone heard of the Macrodakis competitions in forecasting? So the M4 actually just completed. And they take various time series and they try different, it's like a competition. And they try different approaches to see which will be the best approach, and specifically trying to look at machine learning to see if it can improve on it. So the result of this is that machine learning processes do not perform better than traditional time series models. In fact, M4 came out in the spring of 18. This quote I have is from M3, which is the prior competition. But the M4 results were actually pretty interesting. So the things that came out of M4 were that actually a combination of statistical methods were the dominant kind of forecasting processes. So not just a statistical forecasting approach, not one, but if you combine them, you get a better result. So it's this kind of ensemble forecasting approach. The other thing that came out of it was the machine learning forecasts of time series. The 6 kind of top machine learning models didn't perform very well at all, actually. So just pure machine learning methods just underperformed. Purely machine learning methods underperformed time series. But the opportunity is when you combine machine learning methods with traditional time series approaches. And that's where they started to see some real benefit and some real value. So this is my simple modeling framework. I was going to try and throw like crisp DM or something up there, but basically this is what it is with forecasting. So traditionally, you get your data, you do some modeling, then you track the results, right? This is maybe the 20 years ago traditionally. It's pretty labor intensive. It's usually pretty specific to the particular problem you have, and it can be labor intensive, right? So if you really do forecasting right in the academic sense, I think it probably takes a while. There are systems and platforms that do handle lots of forecasting time series very well. So I don't want to mislead you to think that, okay, well, there aren't processes that can handle a lot of forecasts currently. But the proposition of big data today is that it's even bigger. The problem set is even bigger. And the speed is also something, the speed to develop these models is something that's also different. So can machine learning help us improve on our forecasting processes that traditionally may have taken longer times to develop or a little bit more labor intensive, et cetera? What can machine learning do to help us with that, right? So I would say machine learning isn't necessarily going to help us account for all the randomness, but where you start to see a pure pattern have some bumps in the road, some unexpected things happen, machine learning can help us augment our forecasting processes And so I would ask, so can machine learning, for example, learn the art of forecasting? So that manual process of creating the forecast, can we train machines to do that process and then speed up the development of forecasting algorithms? Can it automate model specification? That's one of the things I think that came through in the M4 competition. Actually, the thing that when they were looking at blending the various forecasting approaches, they were using machine learning to determine the weighting that they should use for each of the forecast methods to get a better result, for example. Can it do things like identify outliers and find causals? I think this is something that if you add additional data beyond just your time series data and apply some machine learning approaches to identify what things might be driving those errors in your forecast. And then continuously scan new data. So as you get new data in, can you use machine learning to handle all that volume at a accelerated pace to help you provide a better forecast for your business, whereas you may be limited by doing that yourself currently. And then, things never kind of stay constant. There are always changes in the macro economy. Unexpected events happen. So can machine learning or AI approaches help adjust to those shifts in your time series and adjust quickly so that you're actually providing the right forecast given a new, let's say there's a downturn in the economy, et cetera. So that's kind of my thinking around machine learning, data science applied to kind of traditional forecasting approaches and business forecasting. So just one last thought. If you actually believe the media back in 2012, does anyone remember this? The world was going to end, right? Yeah, there was a movie on. Well, there was a bunch of movies about the world ending, actually. Did anyone have like an end of world party? No? No one showed up. It was really weird. But so this is just to call out that you can have a model, and the thing about the Mayan calendar is it's actually pretty accurate, right? It's pretty spot on. So that it lended kind of credibility maybe to people who are saying, well, it looks like it's going to stop. So did the Mayans know something about some alignment of the black hole at the center of the galaxy, et cetera, whatever, or this kind of Nibiru, I guess. I had to do some research on Google to find all the conspiracy theory stuff. It's very interesting. But did they know something? But no, really, it was the folks that were making these claims. They just didn't understand the model. And so that's kind of my final point: is that whether you're building forecasting with time series models or with machine learning or adding things together to get a better forecast, you still need to have brains behind it. You need to have thinking behind it to understand what's going on in the model so that you interpret it correctly and you don't throw an end of the world party that no one shows up to. So that's all I have. Thank you.